Hello, this is section 7.2, Systems of Linear Equations in Two Variables. So we're continuing with solving systems. This time these are just going to be two variables and linear equations. So it's going to be actually a little easier than the previous section, I think. So we're going to do elimination for these. So in order to eliminate the x's, we have to make this a -2. So that means I have to multiply the bottom equation by -2, and that will give us -2x plus 4y equals -16. The top equation, I'm going to leave it the same. Nothing's going to change. And now when we add the two equations, we get elimination. So now we have 7y equals -14. Divide by 7, you get -2. Okay, choose whichever of the two equations you prefer. I'm going to choose the bottom one, substitute -2 in for y. And that's going to be x plus 4 equals 8. So x equals 4 when you subtract 4 to both sides. All right, so our final answer will be x comma y. That represents the point of intersection of these two linear equations. So if you have a line and another line crossing, that's what this point represents, the point of intersection. For this problem, we're going to do the same sort of thing. We're going to do elimination, but in this case, I'm going to multiply the bottom equation by -3 so that I can make this a -9, and then I can eliminate. So bottom equation, multiply that by -3, we get -9u plus 15v equals, I believe that's 51. Yeah, -51. Okay, -51. The top equation stays the same. All right, we get our elimination. We end up with 17v equals -51. Divide by 17, and we get v equals -3. Okay, so now we go back and we choose either one of those top equations. I'll go with the top one. So we got 9u plus 2 times v, which is -3, equals 0. Add 6 to both sides. We got 9u equals 6. Divide by 9 and simplify that fraction. You get 2/3. So our final answer is going to be in the form of u comma v, u comma v. All right, the next problem is another system. This time these equations look different because there's fractions or rational expressions involved, but it works exactly the same way. Let's eliminate the x's because we can make this a -4 if we multiply by -2. So when you multiply by -2, you're only multiplying the numerators, not the denominators. So that equation becomes -4 over x minus 6 over y equals 4. The bottom equation stays the same. When we do elimination, you get these canceling because they're opposites, and you get -11 over y equals 5. All right, at this point, I would recommend that you take the reciprocal of both sides. You can do that in math. So if you take the reciprocal of the left side, you get -y over 11. The reciprocal of 5 is 1/5. And now we can multiply both sides of the equation by 11. Actually, sorry, -11 to get rid of the negative as well. So we get y equals -11 over 5. All right, now you choose either of the two. I'll choose the bottom one. So if we substitute for the bottom, we're going to get 4 over x minus 5 over -11/5 is equal to 1. Double negative becomes positive. Multiply by the reciprocal, you get 4 over x plus 25 over 11 equals 1. Subtract 25 over 11. You can change the 1 to be 11 over 11. And so now we have 4 over x equals That's going to be negative 14 over 11. And then I would recommend, once again, take the reciprocal of both sides. And then multiply both sides of the equation by 4. Our final answer is going to be, let's see, 2 goes into 4 twice. 2 goes into 14, 7. So you get negative 22 over 7. So our final answer will be x, comma, y. You can verify your answers by graphing those two equations in Desmos.com. This one is pretty identical. We just have to make this negative 8 in order to cancel with that. So I'm going to multiply the bottom one by negative 2. Equation becomes negative 8. I'm going to leave a little bit more space. Negative 8 over x plus 2 minus 24 over y minus 5 equals positive 2. This one will stay the same. Let's add the equations together in order to eliminate. And now we're going to have negative 30 over y minus 5 equals 5. I'm going to take the reciprocal of both sides. Y minus 5 over negative 30 equals 1/5. And I'm going to multiply both sides of the equation by negative 30 in order to get the denominator out. Y minus 5 is going to equal to negative 6. Add 5. And our final answer for that is negative 1. All right, let's choose. I'll choose the top equation this time. Doesn't matter though. So if you do that, you should get 8 over x plus 2 minus 6 over, instead of y, it's going to be negative 1 minus 5 equals 3. So that's going to be 8 over x plus 2 minus 6 over negative 6 equals 3. Well, this is going to be a negative 1, so this is going to be a plus 1. Subtract 1, you get 8 over x plus 2 equals 2. Take the reciprocal of both sides. Multiply both sides of the equation by 8. Subtract 2, and you get 2. Final answer is going to be 2 comma negative 1. And we now have a couple word problems to go. So let's try this one. It says the price of admission to a high school play was $3 for student and $4.50 for non-students. There's a total of 450 tickets that were sold, and the amount that they brought in was $15.55 and 50 cents. How much of each kind were purchased? Well, let's start with writing two equations. The first equation will be the number of student tickets plus the number of non-student tickets has to equal 450 because that's the total number of tickets total. So I'm going to define x as student tickets, y as non-student tickets. All right, and then the price of the student ticket is $3, so 3 times x plus 4.5 times y has to equal the total amount of money that was brought in, which was $15.55 and 50 cents. And now we have our two equations, and we can go ahead and do elimination. So I'm going to multiply the top equation by negative 3 in order to cancel these out. So we got negative 3x minus 3y equals 450 times 3, or negative 3, is negative 1350. This equation remains the same. Add, and we should get elimination here. We get 1.5y equals 205.5 divided by 1.5. And we end up with y equals 137. So that's the number of non-student tickets that were sold. Now we have to figure out how many student tickets were sold. I would recommend the top equation. Substitute 137y. Subtract that to both sides. X will be 313. All right, so that's the number of tickets that were sold of each type. Student, non-student. All right, the last problem is a motorboat made a trip 4 miles upstream against a constant current in 15 minutes. The return trip with the same current took 12 minutes. Find the speed of the current and the equivalent speed of the boat in still water. Well, usually we use the units miles per hour when talking about speed of cars or boats or whatever. So we're going to write our answer in miles per hour. So we know that the relationship is rate times time is equal to distance. So I'm going to create a little table to help us out. So let's draw a couple of categories. All right, so distance, rate, and time. We got upstream. We got downstream. All right, so let's see. What do we know about the distance? The upstream distance was 4 miles. So that would be 4 for upstream distance. And it took 15 minutes. Well, how do we convert minutes to hours? Well, we got 15 minutes. We multiply by the ratio of 1 hour for every 60 minutes. And so that gives us 15 over 60 hours, which is 1/4, I believe. Yeah, it should be 1/4. So this would be 1/4 of an hour. All right, the downstream, the return trip with the same current took 12 minutes. So 12 minutes, if we convert that to hours, we're going to get 12 over 6 this time. Hours, which simplifies to 1/5. Yeah, so that is 1/5 of an hour. So that makes sense because it should take less time to go downstream. And we're assuming that it's the return trip, which implies that it's the same distance. So we're traveling the same amount of distance, 4 miles in both directions. They want to know the speed of the current and the speed of the boat in still water. So we're looking for two speeds, one of the current and one of the boat in still water. Well, if you're going upstream, that means you're going against the current. So that means your boat is going to be slowed down by the current. So you're gonna have the speed of the boat minus the speed of the current. And when you're going downstream, you're going to be going faster. You're going to be going the speed of the boat plus the speed of the current. Well, now we can use this relationship to write two equations. So the top equation will be rate times time equals distance. So we got rate times time equals distance for the first equation. For the second equation, same thing, rate times time equals distance. Let's get rid of these fractions. The way we get rid of the fractions is by multiplying by the denominator. So times 4, both sides of the equation, times 5, both sides of the equation. And so now the new equation becomes r minus c equals 16. And this one is r plus c equals 20. And now we can do elimination. And we get 2r equals 36. R equals 18 miles per hour. So that's the speed of the boat in still water. We still have to find the speed of the current. So I'm going to use this equation. R plus c equals 20. I know r is 18. So if you write that equation, you substitute 18 in for r, you're going to get 18 plus c is equal to 20. So what I did is I plugged in the 18 for the R, and I have 18 plus C equals 20. Subtract 18 both sides, and that gives you 2 miles per hour for the current. So we got the current, and we have the boat. And that is the end of this section.